go with our third topic. We have explained the basic working principle of steam turbine, gas turbine, dual fuel, and its different parts, including the advantages and disadvantages. Okay, so let's go. So we have here a basic working principle of a steam turbine. So how does this work? So for example, we have here a this is a schematic diagram of geothermal energy utilization. So usually in Leyte, we have here the a geothermal energy, which is the, what's the name of this? Tungonan. We have Tungonan, and Tungonan is generating electricity. But what is the principle here? So in Tungonan, they usually have steam from, since Tungonan is near a volcano or something, so near hot area, it's a volcano. So these volcanoes, usually they put water in around the volcano, and this water will create steam. Okay, so this steam will be produced because of the hot volcano lava or magma or whatever. So this steam will be generated because of the hot area in around the volcano. So these areas, these are the production wells. So this water will be turned into steam. So this steam will be put, okay, let's make a drawing. So steam will be used to create a rotational motion, and this rotational motion is connected to a generator, and this generator will create electricity going to a transformer and into the lines into our homes for electrical use. So that is the basic working principle of steam turbine. So this is a turbine connected to a generator. So another, here we also have another source of steam, and this steam will rotate our steam turbine. And since our steam turbine is connected to a generator, the generator will create electricity and give it to a transformer and supply it to the consumers. Okay, and those water that will be those water that we don't really use anymore, or the steam we don't use, we put it to a cooling tower and let it cool down back to water, and those water will be sprayed back around the volcano. So that's how steam turbines work. But on ships, since we don't have volcano on ships, of course, so we have another equipment that will produce steam for our turbine. So we have a steam boiler. Okay, so this steam boiler, so there is water in here and there is a fire. So those water will be heated up and will become steam. So those steam will be the one that will create a rotary motion for our turbine. So that if the turbine rotates, also so will our generators rotate. And then if the generator rotate, it will produce electricity. Or it depends on the ship. So for example, if your turbine is connected to a propeller, for example, so you will have to use a reduction gear, and then you can put a generator in here, and then a reduction gear in here. You can put another one, so you can connect it to a propeller, so you can also use that as a propulsion. Okay, so that's the basic working principle of steam turbine. Next, what are the basic parts of a steam turbine? So we have here a steam. So this steam will rotate our high pressure stage, and then since after that, the steam that is used on the high pressure stage is still usable steam, so it will go to the intermediate pressure stage. It will rotate the turbines in here in the intermediate pressure stage, and the steam will still be, you can still be used on the low pressure stage before it goes back to the condensate tank. So those are the primary parts of the steam turbine: the high pressure stage, the intermediate pressure stage, and the low pressure stage. So another parts of the steam turbine, in the high pressure stage, we have high pressure turbine. Here we have the high pressure stage. There are nozzles and nozzles in there so that you can rotate the turbine, high pressure turbine. And then the rotor is here, so the rotor is the one rotating. So there are nozzles in our blades in our turbine, and there are also blades. So nozzles and blades are used so that to create rotation on our rotor. So those are the parts. Next, we have here the basic principle of gas turbine. So in the gas turbine, air enters here in our compressor. This is the compressor. So air enters into the compressor area, and then this air will be compressed, creating high temperature and high pressure of air. And after that, there is an injector here. This one is an injector, fuel injector. So as the air is compressed, creating high pressure and high temperature, fuel is injected in between, and when the fuel is injected, the fuel will ignite, creating combustion into the turbine area. So this is the compressor. We have here the turbine, and then those combustion will be the one that will create a rotation on the turbine, and then exhaust will be evacuated outside. Okay, so this rotation, the rotation of the gas turbine, can be used. So if ever your gas turbine is connected to a generator, so let's put it here. We can put a reduction gear. We have here a generator, or we can put another one here. We can put also propulsion if you want. So just reduce the speed. So the rotation in here will create a mechanical energy that can rotate our generator for electrical production, or also you can put a propeller so that you can move the ship. So whichever is capable, or it can be used depending on the ship that you will be. Okay, so that is the working principle of a gas turbine. So it is just as the same with the steam turbine, except that the steam turbine uses steam to create rotation, but on our gas turbine we uses the air with fuel to create a combustion that will help rotate the turbine side of our gas turbine. Okay, so what are the basic parts of a gas turbine? We have here the compressor. This is the compressor in which air is compressed. We have the injector in which fuel is injected. We have the combustion chamber in here. So usually gas turbine is also used on our airplanes and jets. And then after the combustion chamber, we have the gas turbine. This is the turbine. And then this is where the exhaust exits. So you can put nozzle here if you will be using this one for jet propulsion. Okay. So here we have an example of a combination of gas turbine and steam turbine. So first we have here a gas. Air is compressed, and then fuel is injected, creating combustion, and then helping rotate the turbine. And the exhaust in here is used to create exhaust here is used to create steam on this part of the coil. So there are water in there, and then that water will boil and become steam, and those steam will be used to power the steam turbine. So this is a combination of the gas turbine and steam turbine combination, and these both are connected to the generator. So the generator will rotate better, will have better efficiency, and lesser energy losses during this combination or combined cycle power plant. Okay, lastly, we have here the basic working principle of diesel fuel engine. So let's use this first. So in a diesel fuel engine, it is like the diesel engine, but there is an additional fuel in here, the gas fuel. Okay, so how does this work? First, we have the inlet. So during the inlet, air enters in here, and then gas fuel is also injected in here. So there is a combination of air and gas fuel that will enter the combustion chamber. After the inlet, compression takes place, compressing the air and gas fuel mixture. And when the piston is at its top dead center, the fuel here, the liquid fuel, is injected, creating combustion inside the chamber. So after that, power stroke there will be combustion, and then power stroke will be made, and then after the power stroke will be the exhaust stroke. So the only difference is during the intake stroke, air enters with a combination of the gas fuel. So that's how it works. Okay, let's go in here. So this is a different type of engine. We have the different manufacturer. So in this one, first air enters. Okay, and during the compression stroke, gas fuel is injected during the compression stroke, and when the piston goes on top dead center, another fuel is injected. So this is the liquid fuel that will create the combustion inside the chamber, creating power stroke and then exhaust stroke after. So the difference in both, okay, let's erase. So the difference here, gas fuel is injected during the intake stroke, but on this type of engine, gas fuel is injected during the compression stroke. So both uses dual fuel. So both gas fuel and liquid fuel. So that's the basic working principle of a dual fuel engine. Okay. Okay, so what are the difference of the three: steam turbine, gas turbine, dual fuel engine? So efficiency. So steam turbine has high efficiency at constant load, excellent for power plants. Gas turbine has high efficiency in combined cycle systems for quick startup. And dual fuel engine has high fuel efficiency with the flexibility to use different fuels. So for fuel flexibility, can use a variety of fuels: coal, nuclear, biomass, etc. While for gas turbine, can operate on natural gas and liquid fuels. For dual fuel engine, operates on both gas and dual diesel fuels. Emissions. So steam turbine has low emissions when paired with renewable or clean energy sources. Gas turbine has lower emissions with natural gas as fuel. And dual fuel engine can switch to lower emission fuels to meet environmental regulations. For maintenance, so steam turbine has long operational life with proper maintenance. Gas turbines, fewer moving parts lead to reduced maintenance. And dual fuel engine, lower maintenance compared to traditional diesel engines. Power output, high and stable output for large-scale applications for steam turbine. High power to weight ratio, compact design for gas turbines. And for dual fuel engine, provides high torque and reliability. Startup time, not applicable for steam turbine. Gas turbines, quick startup, ideal for peak load demands. And dual fuel engine can switch between fuels during operation. So for steam turbine, we usually heat up first the water to create steam. So startup time is a little bit time consuming. Okay, for applications, steam turbine used in power generation and marine propulsion, and gas turbine common in aircraft, power and naval vessels, power plants and naval vessels, and dual fuel engine widely used in marine and industrial applications. Okay, disadvantages. So steam turbine has poor efficiency at low loads. Gas turbines are efficiency drops significantly at partial loads. And for dual fuel engine, efficiency depends on fuel type and load conditions. Startup time, slow to start and respond to load changes for steam turbine. Faster than steam turbine but slower than internal combustion engine for gas turbines. And requires time to adjust to fuel switching, that's for dual fuel engine. Cost, high capital and maintenance cost. Gas turbine, high initial cost and fuel cost. Dual fuel engine, expensive to implement due to dual fuel system complexity. So let's talk with complexity. Steam turbine requires large, complex systems for operation. Gas turbines uses high engineering complexity for design and maintenance. And dual fuel engine, complex systems for fuel switching and injection. So fuel availability depends on the availability of specific fuel types. reliance on high quality fuel, so for gas turbines, and for dual fuel engine, gas supply infrastructure needed for optimal operation. Size and weight, large and bulky systems for steam turbine, lightweight but requires large cooling system for gas turbines, and for dual fuel engine, heavier than gas turbines due to dual systems. Okay, so that's it for now. Thank you for your time and see you on our next topic.